Okay, our objective for today, I can summarize data and compute the measure central tendency, tell you never what concept we're still on. So today, as I mentioned yesterday, we're going to add a couple more things to what we did yesterday, but from there we're going to do a separate example where we crank it up about 5 notches, and this is where it starts getting interesting, the data, okay? So to get started though, just to make sure that we understand what measure central tendencies. Yesterday we did the FAIR model, mean, median, mode, and of course we said that the non-example we're going to use what? The data and the range. Came up with hashtags and so on and so forth, right? From there, you guys wrote down steps. From there we moved on to example 1A. Is that correct? Okay, so we're going to do this one more time. Copy this, please. Example 1A, find the mean, median, mode, and range of the data set. And someone pointed out earlier, they're like, Mr. Q, they're right there. Okay, then let me change the wording to compute. Compute the mean, median, mode, and range. Okay? Then right after you write that, I want you to write identify the IQR. Interquartile range. Okay? So just to recap what we did yesterday, first things first, step 1 is arrange values from least to greatest. So we do 1, 2, 2, 2, 4, 4, 7, 8. Step 2, compute the measures of central tendency, which are the mean, median, and mode. To compute the mean, we add all the numbers and divide them by how many numbers there are. So there's 8 numbers. So if we add this, it's 8 plus 2, that's 10, 10, 30. So that's 30 divided by 8. So that is 3.75. The median. The median is the number in the middle. So we have 8 numbers. That means there should have 4 numbers on each side of the middle. So if we look at these 4 right here, there's another 4 over here. Is there such number in the middle? No. So if there isn't, we take the 2 closest numbers, add them, and divide by 2. And that gives us 3. And that's our median. From there, the mode. The mode is a number that repeats most often. In this case, the one that repeats most often is 2. Step 3, compute the range. To get the range, you take the largest data, which is 8, subtract using the smallest data, which is 1, and that gives us 7. Okay? And yesterday's home play, there were 8 problems just like that, but with decimals, and I gave you a, okay? So with that said, we're going to add a little bit more to this. First of all, writing utensils down, let me go over the terminology that I added at the end. Focus, please. Here's the terminology. I'm pretty sure you understand what the range is because we know how to do that. Is that correct? So the new term that we need to cover is interquartile. Let me cover the word quartile. Quartile comes from the root word quart or quattro in Latin. Quattro meaning 4. So that means that we're going to take our data and split it up into 4 sections. That's why it's called quartiles. So, to get started, the very first step to get the quartiles, you need to find the median. How do you find the median? Well, it needs to be arranged from least to greatest, and you go and signal the median. So, here's the median. The median is in the middle. Since we don't have any, we added these two. That's 6 divided by 2. That gave us what? 3. That's our Q2, or quartile 2. Copy that. From there, I'm going to focus on the lower part of the data, because now I need to split this into 2 sections, don't I? So to do that, I'm going to do this. Look up. I'm going to cover this for right now so you guys can see only the bottom part of the data. How many numbers do I have? 4. So to split it up again into 2 sections, I need to find the median again, but just of that section. So how to find the median? Is it in order already? Yes. In the middle is about right here. Is there a number there? No. So what do? What is 2 plus 2? Divided by 2, that's 2. So this is our Q1. Label that. Yes, sir.
What happens if it was an odd number?
Then you would go with a number that's in the middle.
Wait, I don't get it.
Sorry?
If you had an odd number, would you leave out the rows? Oh, so you'd only have a Q1 and a Q3.
Yes. Next. Ready?
Yeah.
All right. I want you to find me the Q3, please. Q3. Okay, we got it? Yeah, it could be a decimal.
Oh, okay.
Connor.
5.5.
That is correct. It's right here. 5.5. How do we get that? 4 plus 7, 11 divided by 2. And that's our Q3. Let's see if we divided our data into 4 sections. Let's see. Quadrant 1 ends right here, or quartile. Quartile 2 ends right here. Quartile 3 ends right there. And quartile 4 ends over here. 4 sections? Yes. Okay. So now that we have quartiles, let's see what they're asking us to do with that. It says, identify the interquartile range. So look at the quartiles. Tell your neighbor what to do in order for us to find the interquartile range. Yeah, but right now we're looking at the ones we have there. Okay, let's see. What did we do for this one when we found the range for the regular data? Largest from the smallest. So our IQR is Q3 minus Q1. That means the IQR is 5.5 minus 2. That means our IQR is 3.5. Does that make sense?
Yeah.
So instead of using the whole data, you use the Qs in order for you to find the IQR. Okay? Some of your experience, how comfortable you are with this so far? All right. I'm going to have you do one by yourself. Here it goes. Example 1B. There's the data. Copy that, and I want you to find me the mean, median, mode, and range, and also the IQR. So. All right, so step 1, arrange from least to greatest. 1, 2, 3, 4, 5, 5, 6, 8. Step 2, find the measure central tendency, the mean. We find it by adding all of these and dividing by 8. So that is 10, 20, 34 divided by 8. So that gives us 4.25. Hands if you got that. Okay, good. The median, there is none. But if we take the 2 in the middle, so that's 4 plus 5 divided by 2, that's 9 divided by 2, which is 4.5. The mode, the one that repeats most often, is 5. The range, take the largest and subtract the smallest, that gives us 7. The IQR, let's see, Q2 is 4.5, Q1 is 2.5, and Q3 is 5.5. So my IQR is 5.5 minus 2.5, so my IQR is 3. Hands if you got that. Okay, so show me if your fingers how comfortable you are with that up to right there. Okay, yeah, we got this, yes? All right, so yesterday we covered, from there we went to some word problems, which is pretty much about the same process, yes? The only thing we included today was the IQR and how to find the quartiles. Is that correct? All right, but then we get to this part of standard deviation. So standard deviation, like I mentioned before, is one that most people see it as a challenge. But I'm going to break it down by parts to make sure that everybody understands what we're looking at before we get started with it. Okay? So, the formula for standard deviation is as follows: equals to the radical of the sum of the, we call it the chi minus, the number minus chi squared, and that gives us squared deviation. From there we take the square root for it to get the standard deviation. So you're like, I have no idea what you're talking about. So that's why I'm going to break it down. So here we go. Standard deviation. Write your utensils down, look up to the screen. I'm going to first break down the terms to understand what they're talking about. So here are two terms. Standard. When somebody sets a standard, that means that that's something that everyone could probably most likely accomplish. For example, if I was to take a survey of this class and I would say, how many minutes do each of my students invest in their home play every day? I'm going to say that probably not an hour or more. So I'm going to bring down the standard or lower the standard to 30 minutes. So the standard for this class, I'm assuming people could at least invest 30 minutes a day for doing your home play. Now, for those of you that have been staying with me in tutoring, we pretty much hit that mark, and we finish. For those of you that are at home, it probably takes you twice as much. So, but the standard, I'm thinking everybody could do at least 30 minutes. Is that correct? Okay. So that's what we call standard. However, the word deviation means something else. It means to drift away from. You're like, what does that mean? Okay, let me put it in other words. To move away from. So, let's read it now from this way to that way, using, instead of deviation, what am I going to use? To move away from. So this means to move away from the standard. Okay. So if I move away from the standard I set, that means that there's some of you that might invest 5 more minutes every day. So you would be at what? 35 minutes. But with that, I increased 5. I can assume that there's also some of you that don't invest 5 more minutes. You actually take away 5 minutes from the time. So that would bring you to what? 25 minutes. So what I just did right there, that when I set that extra bar away from the standard, that's what we call standard deviation, how much it's away from the standard. Does that make sense? So that would be one standard deviation. If I go another standard deviation, that means another what? Plus 5, and over here another what? Minus 5. So where would I be over here now? 40 minutes, and over here there should be some of you that only do what? 20 minutes. And that's another standard deviation. And so on and so forth. Everybody understand? That's what standard deviation means, that we go away from what was set to be the norm or the average. Everybody understand? You're like, Mr. Cuba, where are you coming up with those numbers? Well, right now I just made this up. I made up in my mind, I'm thinking, well, at least I'm pretty sure they can do 30 minutes every day. And I'm assuming I made up this number. I'm thinking like, I'm assuming people could invest at least 5 more minutes, or I'm thinking some don't invest 5 more minutes, and so on and so forth. Does that make sense? So I made up those numbers. But today I'm going to show you how to come up with this number, the plus minus that number, that what we call the standard deviation. Now, how does it look in statistics? Look up, please. In statistics, of course, every time that they put data together, they represent it on the graph. The graph that they most likely use is called a bell curve. Who's heard of that? Okay, good. So here's our bell curve, and a bell curve looks like this. Yeah. Yes, it's like a bell. So if they were to represent what the situations that I just mentioned about this class in this graph, they would write down here minutes invested in math home play. And over here would be the number of students. These are minutes, number of students. So what is our standard? The standard is the one that I'm assuming everybody could hit here. I said it was what? 30. Okay. So now, and what did I say? We're looking for standard deviation. So the standard deviation will be each time it goes plus minus, plus minus. That's the standard deviation. I said in this case, I said 5 minutes. Is that correct? Could I have made up 10 minutes? Yeah, it could have been 10 and 10. But that's what we mean by standard deviation, and that's how it starts dividing the data. Okay? So, with that said, turn your paper over. You're going to need some space.
Standard deviation time.
Copy example 3. It says, yes, everything. Calculate the standard deviation for the temperature data for the month of April. April high temperatures were 77, 86, 84, 93, and 90. Underneath that, you're going to copy a table. It has 3 columns. The first column says data value, comma, x. Second column is deviation from mean, x minus, and then I'll show you the symbols, what those mean, and square deviation. Copy that, and then I'll go over a couple of those terms. Okay, here we go. Write your pencils down, look up to the screen. So, before I get started, I'm going to go over some symbols that we're going to be using just to make sure that we understand what I'm talking about or what we're looking at in regards to our table and all the work that we're going to do. So the first symbol that I'm going to be using is the variable x. The variable x will stand for the number or numbers from data. The second term or variable or symbol I'm gonna use is this one. X with a bar on top. X with a bar on top is known as what we call chi. Chi is another term that we use for what we know as the mean. Are we there so far? Yeah. And lastly, I'm going to use this symbol. Look up this symbol, like a circle but with a little flip at the top. That's a Greek letter known as sigma. Sigma is the letter S. The letter S is going to replace us writing standard deviation because we can write which letter first? S, but in Greek is this one, standard deviation. Everybody understand? Okay, so with that said, let's begin. I'm going to use this table to guide us first, and then we're going to do some work right underneath. Look at the first column. It says data value X. What did we say X was? Numbers from data. Do we have those numbers? Yes, right here. So how are we going to write them in there? From least to greatest. 77, 84, 86, 90, and 93. Okay? Pretty simple? Okay? Next. Now that we fill the first column, the very next thing that we're going to do after we fill that information, I want us to find chi. Do that, please. Go. No. What? No.
What do you say?
I said to find chi. Go.
Oh!
Okay, my bad. Calculate chi. Okay? So, what'd you get? Cooper, since you're making jokes. Still calculate. Let's calculate outside. Go. All right, Justin, what'd you get? Okay. Step outside for a little bit, please. Selena, what'd you get? 86. Hands if you got that. That is correct. What is chi? The mean. How do we find the mean? Add all the numbers and divide by the number of numbers. So this is 430 divided by how many numbers? 5. Any questions up to right there? Okay. Next, look what this says. Deviation from mean. You're like, I don't understand that, Mr. Q. Okay, let's look at the symbols. X minus chi. What do I write here? Tell your neighbor, please. 77 minus 86. What do I write here? 84 minus 86. What do I write here? 86 minus 86. What do I write here? 90 minus 86 and 93 minus 86. That's all we do in the middle column. So just to recap, first column, we write the numbers in numerical order from least to greatest. We find chi, which is what? The mean. Once we do that, in here we write the number minus the mean. Let's go to the next column. Squared, 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 squared. What should go in there? Let's see. A number minus the mean. So what is 77 minus 86?
Negative 9.
Negative 9. So what is negative 9 squared, everyone? 81. 84 minus 86. Negative 2 squared. That is 4. 86 minus 86, 0 equals 0. 90 minus 86 is 4. 4 squared is 16. 93 minus 86, that's 7. 7 squared is 49. Are we there so far?
Yeah.
Okay, so check this out. These in order, we found chi. Then we did the operation here, which is the number minus chi. Then we did the square deviation, which is this. So now guess what we're going to do with all these numbers again?
Add them up.
You're going to find chi again, but now that's going to give us standard deviation squared. When we find chi again, it's going to give us what? Standard deviation squared. Now, this is where some people get confused. Let's stop really quick. Remember when we solved systems of equations using substitution? Where were people getting confused? Because we substituted once, solved, and guess what we did again? Substitute again, and solved again. That's pretty much something like this. Everybody following? So let's find chi. What is 81 plus 4?
85.
Plus 0?
85.
Plus 16.
100.
101 plus 49? 150. But then we need to divide by how many numbers? 5. So that gives us equal to 30. Are we there so far? Yes? All right. But we're still not done. What are they asking us to calculate? The standard deviation. What is standard deviation? What symbol? This one. Look at it. Is that what we have at the end? No. What can we do at the end? So that's going to give us standard deviation approximately. I want you to round it to the nearest tenth. Tenth.
Is it sigma or sigma?
Sigma. Sigma. So, this is in between what? 25 and 36. So this should be approximately plus minus 5.45. If we round to the nearest tenth, is 5.5. You guys remember how to get that? Yes? Okay. So, let's see if it's the process of this is a little confusing. The only confusion might come at the end when you have to do the chi again. So, arrange, find the mean. Here, the number minus the mean. Here, you square that. And then you find chi. And what does that give us? The square deviation. And to get the standard deviation, you just take the square root. So what does that mean? What was our standard? Where did we set the bar at? 86. So let's draw a little bell curve right here. So then here down the middle, we're going to label that 86. So that means that if the standard deviation is plus minus 5.5, that means going this way.
Plus 5.5.
So what is 86 plus 5.5? 91.5. However, there's some that are, or the temperature is going to drop. So this will be 80.5. Guess what? This is what we call, look up, standard deviation number 1. We just put the little symbol. Yes? 5.5 minus 86, 80.5. Next, if I go one more standard deviation, look up. 91.5, add 5.5, that's what? 97. That's, look what I'm going to write. Standard deviation number 2. Standard deviation 2. So that means this way, what is 80.5 minus 5.5? That's 75. That's standard deviation number 2.
And then 69.
So if we go one more to the third deviation, standard deviation, where are we going to be here? Plus 5.5, that's 102.5. That's third standard deviation. And over here, minus 5.5, that's 69.5. That's third deviation. Does everyone understand how each deviation takes us away from the standard? Yeah, which is the mean, yes?
Well, whatever say, like, find the fifth.
I then get our colleagues.
Oh, ask them if they sound tired.
Yes. Yes, they're going to ask you to find the standard deviation. They're not going to ask you to graph it, but they're going to ask you to compute the standard deviation. Okay, guys, your attention really quick. What I just showed you with the bell curve, I wanted you to understand what each deviation does and what it means. Now, are they going to ask you this on the home plate? No. All they're asking you to find is this part right here. So what does that mean? That you're going to have to do this table by yourself and fill in the information given data. Yeah.
So, on the other side,
yeah, there's standard deviation here on this side and on that side.
Cooper, did you phone something?
On each side of the standard, it's either adding or subtracting. So, our home plate for tonight. Page 438, numbers 5 through 12 only. Justin and Cooper stay behind. Have a good one, guys. There is no tutoring. I have a meeting after school. Have a good one. Enjoy your home play. See you guys tomorrow. Bye.